Hello everyone, hope you're doing well. In this video, we'll look into the next part of vectors. To start with, we'll look into resolution of vectors. Now, what is resolution of vectors? It is a process of splitting up a vector into two or more vectors such that their sum is given is the given vector, right? So I'm dividing the given vector into smaller parts. That's called resolution of vector. Now, this split of vectors is called resolution of vector. Now, resolution of vectors can be in any way. So something like, let's say I have a vector A. I can go like this, something like this. Let's say this is vector A, this is B, this is C, D, E, F, G, H something. So all this. So I can say this A equal to B plus C plus D plus so on. I can have infinite parts of this. Or if I just take a triangle, I have one vector, I draw it like this. This is A, let's say this is B and this is C. Then I can say A equal to B plus C, where B and C are what? Are the components of vector A. Alright. So what is resolution of vector? It is splitting a bigger vector into smaller vector. Now, general resolution might not be very helpful for us. So what we go for is we go for something called rectangular resolution. So in rectangular resolution, what we do is we only find the components which are mutually perpendicular, right? So in this case, you can see we have a vector A which makes an angle theta with x-axis. Then AX is given as A cos theta. So that means x component of this vector is A cos theta. Similarly, AY is given by A sin theta. So that is Y component is A sin theta. Now AX and AY, so I can draw AY here, are rectangular components of vectors. They're perpendicular to each other. Now resolving a vector into rectangular components helps us a lot. For example, let's say I have a body. I'm applying a force F in this direction. I want to find work done. So I know that this force is not responsible for work. Only force which is parallel to motion is responsible for work. So what I do, I find this component and this component. Now I see that this component is F cos theta and find displacement, then F cos theta into displacement is work. So because I could resolve this vector into two rectangular components, I could do it easily. So in this way, rectangular resolution of vector helps us a lot in solving questions. Then we have scalar product of vectors. Now when I multiply two vectors, there are two ways that we have. One is called scalar product and other is called vector product. In a scalar product, the resultant is a scalar quantity. That's why it's called a scalar product or dot product. So how do we find scalar product of two vectors? So if I have a vector A and B such that the angle between them is alpha, then A dot B is given by A into B into cos alpha. So magnitude of A into magnitude of B into cos alpha. That's called scalar product. And this is a scalar quantity. That's why we call it as a scalar product. This is also known as, it's also called dot product. So dot product or scalar product means the same, right? Now sometimes if it is in vector representation in ijk, then because it is A dot B, now I dot I would be equal to how much? Magnitude of I is 1. Again magnitude of I is 1. Angle between I and I is 0. So 1 into cos 0, that is 1. Similarly, J dot J would be 1. K dot K would be 1. Now if I look into I dot J, this will be what? 1 into cos 90. So that is 0. So I dot J is 0, I dot K is 0. Similarly, J dot K is 0, right? So if I have a vector A something like 2i plus 3j and vector B something like I minus j, then A dot B would be equal to 2i into I, that is 2 into 1 plus 3j into minus 1 plus 3 into minus 1. I don't have to bother about other quantities because I into j is 0 and j into I is 0 plus 3 into minus 1. So what is the answer? 2 minus 3, that is minus 1, which is a scalar quantity. So in this way we find scalar product of two vectors. So here also if we want to go for further examples based on scalar products. So for example, if I just took that one, let me go for a 3-dimensional example. If I have something like A equal to some I plus 4j minus 3k and B equal to something like, B equal to some 3i minus j plus 4k. Now I need to find A dot B, let's say. So again, as we have seen, I dot I is 1, so 1 into 3. I can write it as I into 3i plus I into minus j plus I into 4k plus 4j into 3i plus 4j into minus j plus 4j into 4k plus minus 3k into 3i plus minus 3k into minus j plus minus 3k into 4k. So I done it just because so that you understand. Now wherever we have I dot j, this is 0, j dot k is 0, j dot I is 0, j dot k is 0, k dot I is 0 and k dot j is 0. So we are left with what? I coefficient is 1 into 3, 3 minus 3 minus 3 into minus 4 into 1, that is minus 4 plus minus 3 into 4, that is plus minus 12. So the answer would be how much? Minus 12 minus 16 plus 3 is minus 13, right? So that means I don't have to write all these terms. Only terms that are non-zero are, these are the terms which are non-zero terms. So I can directly multiply the coefficients here itself. So I can directly write it as 1 into 3 plus 4 into minus 1 plus minus 3 into 4. You'll get the same answer, minus 13. You don't have to write all these things. So in this way, we can find scalar product of three-dimensional vectors also. But vectors are not given in IJK form, then we use this formula A dot B equal to AB cos alpha. Then we have vector product of two vectors. So vector product is also known as cross product. So it's represented by a cross, so that's why we call it as cross product, and it's called vector product because the resultant of the vector product of two vectors gives us a vector quantity. So if I have two vectors, let's say A and B, then the vector product is given by A cross B, which is perpendicular to the plane of this. Here I'll write it as n cap, right? So A cross B is given by magnitude of A into magnitude of B into sine theta. So this vector is always perpendicular to plane of A and B. So if I want to find A dot A cross B, this will be equal to how much? This will be 0 because A cross B is perpendicular to A and dot product of two perpendicular vectors is 0. Then how do we find vector product of two vectors? If it is given in the form of A and B and sine theta is known, we use this formula. If they're given in form IJK, let's say I have vector A. A is given by 3i plus 4j minus k. Let's say vector B is given by I minus j minus k, something like this. Now A cross B would be, can be written as I, j, k. Then the coefficient of A, 3, 4, minus 1. Coefficient of ijk is in B, 1, minus 1, minus 1. Right. Now find the vector product, that will be equal to I into 4 into minus 1 is minus 4. Minus of minus 1 into minus 1 is 1. Minus j into 3 into minus 1 is minus 3. Minus of 1 into minus 1 is plus 1. Plus k into 3 into minus 1 is minus 3, minus of 4. So this is what we have. So from this we get minus 5i plus 2j minus 7k. So this is what is the cross product of two vectors. Hope you could follow this. So this is about vector product or cross product. Hope you could follow this. So what all things we have seen in this? We have seen what is resolution of vector. Then we saw that we are only bothered about resolution in rectangular coordinates because that's what is going to help us. Then we have seen what is scalar product and what is dot product. So thank you very much and keep watching these videos.